All right, good morning everyone. Thank you for joining me today. My name is Aditya and I work as a developer advocate with Salesforce. And today we are going to be talking about how you can use Data Cloud to power your agents. So before we get started, quick forward-looking statements. Please make all your purchasing decisions based on generally available information and not based on what I might share today. And we're going to start off with a statement that no one has ever heard before, which is AI is only as good as its data. So I'm sure you've heard it quite a lot of times. And it's the same case with agents. Agents is also built on large language models. So the better data that you give agents, the better it's going to work for you. But no one talks about how you can give that data and how easy it is to give that data back to agents. With Salesforce, you have Data Cloud. And this is that one tool that you're going to need to get all of the data from any data source that you have and use that data to power not just agents, but the entirety of the Salesforce ecosystem as well. And the best part is that Data Cloud is built on top of the Salesforce platform, which means you need not learn any new skills to start working with it. It works with your flows, your Apex classes, custom objects, and so on. It's very seamless. Now, how does it really work? What does it take to get all of the data and put it to action with agents? So it's a 5-step process. And when you talk about all of this data, remember we are not always talking about only structured data. We are talking about unstructured data as well. So things like your video recordings, PDF documents, chat transcripts, all of that can be also ingested into Data Cloud. And in order to get all of this data into Data Cloud, that is step 1, we give you a bunch of out-of-the-box connectors. So we have connectors with predominantly a lot of systems out there. And in case you're integrating with a homegrown system that doesn't have a connector that Data Cloud is offering, you can even use our ingestion APIs. So there is no bar on what data you can get in. And this goes in for both structured and unstructured data as well. So all the data is going to come in into Data Cloud. Now the second step is going to be harmonizing that data. So this is an important step. I mean, all the 5 are important, but the second step is going to be critical because all your source systems are going to store data in different formats. And you don't even know what formats those are. But once you get the data into Data Cloud, this step is going to transform all of those different formats into one common data format that you can then work with down the stream. And this is important because you can build all of your workflows based on this common data format. And in future, if you decide you want to add a new data source, get in data from another system, all you need to do is set it up in the front, and you don't have to change anything that goes on behind the scenes. So that's why transformation becomes an important step. Now the third step is going to be indexing. Now indexing is crucial because of 2 reasons. First, when you think about structured data, it's going to come in let's say a tabular format or a JSON format. It is structured, and then it's going to sit in the same structured format. But think of unstructured data. Is there a specific format for PDF documents? Is there a specific format for audio and video files? So how are you going to search through those documents? How are you going to write queries on those documents? So that's why indexing is an important step which makes all of the unstructured data queryable. Now there is a second aspect to it. It's not always unstructured data. Even structured data should be queryable, which you always know is queryable, but based on keywords. So you give a specific keyword, put in a where clause, and that data comes back to you. But when you talk about agents and agentic workflows, you're not dealing with rigid workflows that deal with only specific keywords. Now the end users can type in anything that they want, and then you have to semantically match it. When I say semantically match it, it means you search by meaning rather than search by keyword. So think of Google. You don't actually know what results Google is going to return, and you don't put in those keywords. You put in what you want to see. Google takes care of finding the relevant information and returning it back to you. That's how agents work as well. And that's where indexing becomes important, both for structured and unstructured data. Now that you have got your data, it's in a common format. It is indexed and ready to be searched. That is where your RAG comes into picture. So with RAG, you query all this different information, augment your prompts, and then generate a response for the end users. So that's the end-to-end process. And finally, the fifth point is going to be governance. So AI is a new technology and not a whole lot of companies are comfortable with it. So they want to see some reports for compliance reasons. What is happening behind the scenes? How do you report on it? So that is also a capability built into Data Cloud. So anything that Agentforce does, anything that generative AI does is automatically logged and tracked within Data Cloud. So these are the 5 key aspects that Data Cloud enables for agents to work better. Now, if you think of use cases of what agents need, on the left-hand side, you see a whole bunch of things that agent needs. For example, real-time situational awareness. So when a user asks for something, let's say their order status, it needs real-time data. So how do you get that? So Data Cloud is delivering that with the help of unified profiles and so on and so forth. So these key aspects of agents can be met with these features of Data Cloud. So this is a very high-level overview that I wanted to show you. But in a 40-minute session, it is very unrealistic that we can go through all of these. So today, we will be focusing on these 3 key topics. First is data graphs that allow you to get structured data into agents. The second one is RAG, which allow you to get unstructured data into agents. And third one, we are going to see how audit and feedback works. So all the governance part of it, that's what I'm going to cover towards the end. So talking about the first topic, which is data graphs. So data graphs is one of the many ways in which you can query data out of Data Cloud. So with Data Cloud, I said you can get all the data into one place, but it doesn't just sit there. You can take action on it. And in order to take action on it, you need to query that data. And because Data Cloud is built on the same Salesforce platform that all the other apps use, you can actually query for Data Cloud data using flows. You can query for it using Apex. You can get the data using APIs. And most importantly, you can also get it using a data graph. Now, what is a data graph? Now think about this. Think about a person and a lot of information about that person we are getting from multiple data sources. Now what if I want to get all that information at once? How many queries do I have to write? So if there are 10 tables that store information about this person, let's say their browsing history, their cases, their orders, so on and so forth, you'll have to write those many queries to get all of that information back. That is both time consuming and resource intensive. So data graphs is a way for you to get all the data related to one person in one single call. And this data is going to be in a JSON format. And data graphs are pre-created for you based on the data that is currently available. So there is a JSON for every individual sitting in Data Cloud. When you query for it, it just returns it immediately. So that's the advantage of data graph. Now, when you talk about Data Cloud use cases, I'm sure you're familiar that we never say Data Cloud is real time. We tell you that Data Cloud is near real time for most use cases. But we understand there are scenarios where we want real time data to come out of Data Cloud. One popular use case is going to be personalization. Let's say a user is browsing a website, and based on the number of clicks that they are having on a particular product, maybe you want to show them an offer. Now, this is something that you have to do immediately. You can't wait for Data Cloud to process all of the data in, let's say, 20 minutes and then show the results to them. That's not going to work. So what we've done is we've added a real-time layer on top of Data Cloud to enable these real-time scenarios. The only caveat here being the real-time layer doesn't support all the use cases. It's meant for very targeted use cases like web and mobile SDK. So only a few types of events go and hit the real-time layer, whereas all the other events are captured by the normal Data Cloud processing layer itself. Now, why are we talking about this real-time layer? Now, the whole real-time layer, if you want to write a query to get real-time data, it's not possible. Because today, if you want to write a query, you write it on data model objects or data lake objects. And that's something that's not going to store your real-time data. If you want to get data out of your real-time layer, then you will have to do it through a real-time data graph. So data graphs is going to be important here as well. In fact, it is because you create a real-time data graph is all of the process made real-time. So right from ingestion to unification to harmonization, all of that becomes real-time because you have created a real-time data graph. So you don't enable a setting somewhere during ingestion saying that, okay, this is going to be real time, this is going to be near real time. No, you define a real time data graph. So this is quite a powerful feature that enables a whole lot of use cases. Now, one of those use cases, as I mentioned, is personalization, and I was calling this out because we have launched a new agent action that can show you personalized results, all of which you are going to see in a demo just shortly. Basically, personalization is a bunch of rules that you define in the background, and these rules are going to recommend products to customers. And why is it personalization? How is this working behind the scenes? It's working because of data graphs. So personalization takes in two data graphs as inputs. One is the data graph about a person and all of their behavior, and the other data graph is about all the products that you have in your org. So here as well, data graphs become important, which is why I'm stressing a lot, and there is one pillar that I dedicated to in this session to data graphs. So let's quickly look at a demo and see how all of this comes together. So here we are in Data Cloud app, and what you're seeing are data streams, which is a way to get information from external systems or even Salesforce into Data Cloud. So you can see that I've created multiple data streams for different objects within Salesforce, like you have contacts, opportunities, products, so on and so forth. And I'm also getting data from a website. So all the clicks that the user is making on a website, all the products that they're browsing, all of that information is going to come into Data Cloud. Now the next step that I do is map that data into one common data format. So on the left hand side you see the source format, and on the right hand side you see the format that Data Cloud is expecting. Now all you need to do is, it's a very simple interface for you to map the data from a source to a target, so you need not work on a whole lot of things, it's just point and click and it gets done. So one popular object is going to be the individual object. So this is that one object in Data Cloud that stores information about a person. Now whether this information is coming from Salesforce, whether it is coming from a website, your homegrown systems, it doesn't matter. In the end, the data about a person in Data Cloud is sitting in the individual object. Now because you have this data coming in from all these sources, you might run into duplicates, because I as a contact can exist in Salesforce, I can exist in Marketing Cloud, I can exist in some other SAP system. So if all the data comes into the same table, it's duplicate data. So what we are going to do next is unify all of that data together, which happens through a concept called as identity resolution. So what it does is it merges all these duplicate profiles into one single profile, which means all of the related data is merged together as well. So let's say from my website individual, I'm getting all the clicks, and from my Salesforce individual, I'm getting all my orders. Now with unification, what happens is I can see one record with both clicks and orders together. So that's what this unification process enables you to do. Now you might ask, okay, I've done this, but what do I end up with? You end up with a true customer 360. So if you look at this, this is a summary of all the data model objects that are there in Data Cloud. So at the center you have the individual, which is that person, and you can see all that related information about the person coming in from wherever it is. So here you have your personalization, you have products, here you have leads, opportunities. So all of that data of one single person has come in to Data Cloud, which is ready to be queried. But as I mentioned before, if you want to query all of this information, you see how many tables are there that you'll have to write a query on. So instead of that, what you're going to do is you're going to create what we call a data graph. So when you click new and say start from scratch, you see two options. You can create a normal data graph that is going to build data out of your regular Data Cloud storage, and a real-time data graph that builds a data graph on your real-time layer. And this is what enables real-time processing to happen. Now what goes on in a data graph? So let's say I open one of the data graphs that I already created, and you'll notice it is actually pretty simple. All you need to do is define what is the data that should be present in the data graph. So obviously the parent or the top level is going to be the person, and for a person, what is all information that you need to be in the graph? So here I have the browse engagements, I have website engagement, personalizations. If I want, I can put in orders, and so on and so forth. So all I'm defining is the objects that need to be put inside my graph. And once I define this, the graph starts building in the background and it becomes available to you. And this is something that you can query. So here Data Explorer is this feature in Data Cloud, kind of like a list view that lets you see what is the data present in different objects. So here I am querying the data graph that I just created. And you can see for every single person, there is a graph. And let's say I open one of the graphs, you can see it is a JSON structure, where it has the name of the person because that is the top level that I have added. And as the child elements, I have the different individuals, that is their different identities, whether it is coming from a website, Salesforce, so on. And along with that, it has all the related data like their browsing histories and so on and so forth. But you get the idea. All the information of a person present in one single JSON file, which is going to be real time. Now, what are the use cases that you can unlock with this? So first of all, you can query this JSON and you can do whatever you want with it. If it is Apex, you parse this JSON and write your own business logic. If it is flows, write your own business logic. But you can go a step further and you can feed it into a prompt template to enable more use cases. So within a prompt template, as you know, you can add a bunch of merge fields. So it can either be from the data that you already have in Salesforce, like for example, if it is a flow that you want to add as a merge field, you can. If it is Apex, you can. These flows and Apex in turn can query your data cloud objects, data graphs, and so on. So there is permutations and combinations that is possible. Now you can directly add fields from an object. So for example, this is a prompt template that I created for the agent to answer any questions that I have about this particular customer. So I want to know their phone number, it should give me. If I want to know their email address, it should give me. Simple use cases. But what if I want to know something more? What if I want to know, based on their browsing history, what is a product that I can most likely recommend to them, or something like that? Maybe they gave me a call, I want to know something about their browsing history. So think of a use case like that. Now, how do I get that done? So if you go into a contact, you can obviously see all the different fields of a Salesforce contact. Now, if you scroll all the way to the bottom, you will also now see data graphs. So here is the power of Data Cloud being on the same platform. So data graphs is a Data Cloud feature, and Prawn Builder is built on the Salesforce platform, and contact is a Salesforce object. So you're able to pull in a data graph that belongs to a contact from Data Cloud and put it into a prompt template. So you choose data graphs and you see all the different data graphs that we've created in Data Cloud. So here what I've done is I've chosen one of those data graphs, and then I have a basic prompt that says, answer this question based on this data graph. So essentially I'm enabling an entire Q&A segment with all of the customer information in one place and any question that I want that I can ask. So here I'm asking a question, what product is Al Miller, is a fictitious contact. I chose Al because it sounds very similar to, it looks very similar to AI, kind of going by the theme. So what product is Al Miller most interested in? Then if you look at the resolution, the data graph JSON that you have just seen in Data Explorer, all of that gets dumped into the prompt builder. So this is my complete JSON, and then I have the question. And notice data masking and all in place. We are not going to dive deep into that, but this is a security feature that we have where any sensitive data is masked before it is sent to an LLM. Now the LLM is going to have this context, it's going to process all of this, and it just gives me a 2-line answer saying that based on the provided data, Al is most interested in backpacks based on the number of clicks, and it also gave me that they clicked on this product 34 times for whatever reason we don't know, but they are very interested to buy a backpack. Now this can enable a whole lot of use cases for you, whether you want to add this prompt template to an agent and have that conversation. So from the agent you can ask the same question, you're going to get the same response. But what if you want to automate something like this? You'll be able to do that as well because you can invoke a prompt template from a flow. So there is a whole lot of permutations that now get unlocked because you have all the information about the customer in one place. Now we spoke about this data graph, and I also spoke about the real-time data graph powering personalizations. So we have a different app called personalization that lets you create recommendations based on their browsing history. Now, this is not something that is specific to Data Cloud, but Data Cloud powers this personalization engine. Now, what you do here is you build what we call a recommender. So, a recommender is nothing but something that gives you a recommendation. But what are the inputs the recommender needs? If you see, it's only two inputs. First one is the profile data graph. That means who is the person that I have to give recommendations for, and the item data graph. What are the products that I have to recommend? So, these are the two inputs that you give to a recommender service. And then there is some other configuration that goes on, but predominantly these two are the most important when it comes to giving recommendations to customers. So, once you build this out, once you build this recommender, there is a standard action that you can add to your agent that will directly invoke this recommender and give you the responses. So, here I am asking a simple question from the agent that says, can you recommend a product for Al? Then it goes back, looks at the recommendations, which is powered by your data graphs, and then it's going to suggest these three products. I mean, this can be any number that you want, but I've put the limit to 3. And this is one of the use cases that you can now unlock because all of the data is in one place using a data graph. Now, this was the first segment, which is going to be your structured data queried using a data graph. Now, let's move on to the second segment for today, which is going to be RAG, or what we call as retrieval augmented generation. So, RAG is not just for unstructured data, it's for structured data as well, but we have seen people use it in the context of unstructured data, so we'll stick with it. So, to enable RAG on unstructured data, there is a lot more processing that you need to do in the background. So, as I mentioned before, structured data very easily comes into a table, but unstructured data, you don't even know what format it's in. It needs to be processed to be able to be searched. So, the very first step is going to be that processing. And what we do is once we get the data, which is, let's say, for an example, your PDF file, it comes into Data Cloud. The first step that we do is we chunk that PDF file, which means we take the big PDF file, break it down into small paragraphs. And there are different chunking strategies based on what kind of a file it is. Again, you can dive deep into it by looking at the documentation, but just know that the first step is chunking. Now, the next step is what we call vectorization. So, vectorization is a process in which we convert these chunks into machine readable vectors. And because you are converting it into these machine readable vectors, the data now becomes searchable. And this conversion to vectors also happens through a model. And this model also enables you to search using a semantic meaning and not just the keyword. So, vectorization is going to be a very important process that makes the whole data searchable by meaning. And this happens behind the scenes. You don't have to worry too much about it. You just click a bunch of buttons and we take care of processing all the data in the background. Now, once you have all of this data in a searchable format, you know what to do. You can search, pull the data, augment your prompt templates with that data and generate the responses. Now, that is what the next slide is talking about. So, really retrieving the data, augmenting your prompt and generating the response. Now, the reason there are 2 slides for this is because I want to make it very important that it is a 2-step process. First step is to get the data and convert it into vector format, which happens offline. And on the fly, whenever the user makes a request, then you retrieve data, augment your prompt and generate the results. So, that's the reason I've split it into 2 different slides. Now, we also make it a lot easier for you to set up this RAG, in the sense that you don't have to create data streams, you don't have to manually do the vectorization process and stuff like that. All of it we are automating in the background using what we call an Agentforce data library. So, it's a feature that lets you give all of this unstructured data as knowledge to your agent that it can search through and give the responses. We are going to see all of this in a demo, and let's actually jump into that. So, again, what we are seeing here is Data Cloud. All of this is powered by Data Cloud, obviously. And now we are looking at the data lake objects. So, all of the data that is coming into Data Cloud is going to be dumped into a data lake object. Now, when it comes to unstructured data, think of files. You have files in Salesforce as well, like attachments, content documents, and so on and so forth. all of those can come in from Salesforce directly into Data Cloud. And let's say you have these files present in external cloud storage systems, they can come in as well. You just click New, and then you select from external files and choose any cloud storage provider that you want to push in the files from. Now, all of these files, whether coming from Salesforce or through these external systems, are going to sit in these data lake objects. And notice the category. There is one category called directory table. So this is the category that denotes that this is a data lake object that is storing information about files. Now, this is the first step. You got the information, you put it in this directory table. Now, the next step for you is to do the chunking and vectorization process. Now, there are different ways to do it, but the easiest way in Salesforce is to create a search index. So you click New, you see a bunch of different options. Let's go with Advanced Setup so that I can show you everything that happens behind the scenes. Now, with the creation of a search index, the first thing you select is what is the object that you want to create a search index for. Now, as I mentioned before, this is not just for unstructured data, which is why you see structured data like cases and all as well. You would ask, why do I need to search a case by meaning? Why can't I search based on a case number? Now, let's say there are thousands of cases in your Salesforce org, and somebody comes up with a new case. You want to search the existing cases to find a solution on how this was solved before. Now, in that case, you can't search by subject because you don't know what subject it has, what description it has, and you don't even know the case number. So this kind of enables you to have a broader search by meaning. It's going to return the cases back. But yes, moving on. Let's choose one of the unstructured or directory table object. And then you see the different chunking strategies that we allow you to configure. Now, if you would have chosen simple setup, you would have been done by now. But advanced I'm going through because just to show you what Data Cloud is capable of. So for each and every file type, you can choose what is the chunking strategy. Now, you should be well versed with all of these to be able to tweak these settings. I, for one, would leave it just as is. And what you see is a new option that we have just rolled out called Enrich Chunks. So essentially, think of it this way. I told you there is a PDF that comes in, it gets divided into chunks. Now, what happens is when you chunk the PDF, there are these chunks that you end up with which have no relation to each other. For example, if there is a 10-step process in order to achieve something, like to register to TDX or maybe to book a ticket, there are 10 steps that you have to follow. This chunking is going to divide all those 10 steps into 10 different chunks. But all of them, in fact, address the same problem. Now, enriching the chunks, what it does is it maintains that semantical context of all of these different chunks. How it is done and all is a little complicated to explain, but in the background, we maintain all of that context. We know how all of these chunks are related to each other and what each chunk can do. So that's something that happens with this enrichment. As an end user, we need not really concern ourselves with how it is happening in the background. All we need to remember is you check this box and the RAG works better. So that's how it is. Now, let's say you do that, then you choose the embedding model. Embedding model you can choose based on your needs, but we also have, if you notice, a multilingual embedding model. Now, this is really powerful because we are not just dealing with English. Let's say you have a document that is written in a different language like Japanese. You can actually load that into Data Cloud. It gets chunked, vectorized, and I can search that document in English now. So language is no longer going to become a barrier. So that's the advantage that you have with this vectorization. And you can go on. There are multiple settings, but once the chunking process is done, you are going to end up with a whole bunch of different objects that I'm going to show you. So this was the object that I created a search index on. And if you notice, it's a directory table. So it has 4 different PDF files. Now, after I finish chunking, there is an object called chunk that gets created, and you will notice that PDF document has now been chunked into different chunks. So like there is some data. Now, as I mentioned before, it works, but there is no contextual meaning between each of these chunks that is stored. So let's say you chose that enriched option, then you will end up with an enriched chunk that's now going to look something like this. So notice now it's a whole lot of chunks which you haven't created in your PDF, because there are different types. For one you have the question chunk. Like for every chunk we look at what questions it can answer, and we actually store those questions in the same table. So whenever user searches for something, we know what questions they are asking, we can find similar questions and find similar chunks and so on. And then you also have the metadata chunks, which talk about what that chunk has, like tags, a quick summary, the general sentiment of what information is there in that. So all of that is being stored. Now what this enables you to do is you can now query this information, and querying is as simple as writing a SQL query on these objects. So you basically ask a question. In this case, it's a bunch of insurance documents that I uploaded, and I'm asking a question whether this particular customer has insurance coverage or not. Now instead of me scanning through those PDFs, Data Cloud is going to do it for me, and it's going to come back with search results. Now think of this to be like a Google search result. It's going to give you the results ranked by a score. So the higher the score, what it means is that this chunk answers the question more accurately. Now you can put this into a prompt template and kind of summarize the results and return it back to the user. But writing a query is a pro-code approach, and you'll write this query in an Apex class, put that Apex class into the prompt template. It's a whole lot of work. So what we have done is, there is a no-code approach as well. That is, for every search index that you create, we automatically create a retriever. So a retriever is, think of it like a query engine, but you don't have to create it, it's pre-created for you. And for every search index that you can create any number of retrievers that you want. Because it's a query engine, let's say you create a retriever, you get to put filters. You get to limit the number of results it gives out. So a retriever is going to work for you in that way. So now that you have this, what you can do is you can add that retriever into a prompt template. So what you notice here is the retriever as a merge field added into your prompt template. In the previous example, it was a data graph that I added. This time it's a retriever that I'm adding. And you can configure this retriever by saying what is the query that you want to give, and based on its configuration and filters, it's going to return the responses back to you. And that's exactly what I have done. Now if you look at the test inputs, I'm asking the exact same question, whether the person has insurance coverage. And notice again, the retriever goes on, searches through all those documents, comes up with a whole bunch of chunks that answer the question. The prompt template summarizes all of these and gives it back to me. Now all this setup that I have shown you was completely manual. Now I told you Agentforce Data Libraries is a feature that lets you automate all of this process. So Agentforce Data Library is something that you can search from Salesforce setup. And then all you do is create a new library. Creating a new library is like creating a new folder. So what documents you want put in that folder is up to you. So here I have created a demo library just to show you what kinds of things can be put into a data library. First and foremost, you can put knowledge articles. So any knowledge articles that you have in your org, either dump all of them or put filters based on data categories, that's up to you. You can put in knowledge articles into your data library. Then you can upload your own files. If you've seen the previous process, you either had to put in a file as an attachment to Salesforce or then upload it to a cloud storage system. But here you get to upload files directly to the data library. And the third feature that we very recently launched is web search. So using this data library, you can search through the web based on the question and put those web results into use within your agent. Now the thing here is that a single data library can only store one kind of information. So either it is knowledge or file upload or web search, not multiple. Now let's say you create this data library. You can attach this data library directly to an agent. You don't even have to go through the process of creating a prompt template, creating a retriever and so on. Create that data library. In the background, we automatically do the search index creation, so you need not worry about it. So within your agent builder, you will see a tab for knowledge, which is where you can attach your data library. And at the moment, you can only attach one data library to your agent. So now that you attach it, you ask the same question and it gives you the same response back. But this time, it's going to invoke a standard prompt template that we already defined called as answer questions with knowledge. So previously I showed you a custom prompt template that I made for the use case. But then if you are going to use Agentforce Data Libraries, there is a standard prompt template that gets invoked in the context of the library that you attach to your agent. So it's only going to search through the documents that you attach using the data library. It's not going to search through all of the data. So that's how answer questions with knowledge works. So that's again in a nutshell to show you how you can get your unstructured data either using traditional processes or using your new Einstein or Agentforce data library. A summary of the flow. Let's say you're invoking it from an agent. The agent has a topic. The topic has the standard answer questions with knowledge action. The action in turn invokes a prompt template. The prompt template invokes your retriever. The retriever is based on a search index, which in turn is based on your data model objects. So this entire chain happens right in front of your eyes without you knowing about it. So a couple of new features. One is the advanced retrieval mode is something that we are coming up with. So let's say all we are talking about here is user asking a question and agent returning the answer back. But not all users are going to ask questions in a well-structured format. Maybe it's a vague question. Then what we do with this advanced retrieval format or retrieval mode is that we first retrieve the results based on the user's current question. Then we look at the response, we look at the question and decide, let's enrich the question, because now we have context of what the user is looking for. So this is a process, this is a multi-turn process in which we enrich the user's question in the background automatically to deliver better results to customers. And we are also coming up with ensemble retrievers. So right now you've seen the limitation where you can only use like one retriever, one data library and all of that. So ensemble retrievers lets you group a bunch of retrievers together so that you can attach more data sources to your agent. So that's something that is coming out soon, so stay tuned. Finally, moving on to the final topic of today, which is audit and feedback. There are a bunch of different data model objects in Data Cloud that support auditing. Like I mentioned, every single operation that happens in Data Cloud or in Agentforce or generative AI is audited, and all of these DMOs are there in the background. And it's very easy to actually show you a demo, because let's go into the Data Explorer, and if I type Gen AI, you can see all these different objects. For example, if I go into Gen AI feedback, it shows you the feedback that the user has given on a particular response. Remember the thumbs up, thumbs down that is there for every response that comes in? We track it in this object. And we also track a bunch of things like toxicity. For example, if I do Gen AI and go to the category, every response that comes back from the LLM is checked for different parameters, and we identify a score for those parameters, and that is also logged so that you can actually see if the LLM is giving you toxic responses and are those being shown to the user or not. Now, always going to the Data Explorer is a little bit of a headache. So what we've done is we've created a bunch of out-of-the-box reports. So these reports are built on top of the data model objects, which make it really easy for you to actually see the results, which is what I've already opened. So the data that is there in this report is pretty detailed. For example, you can see the exact prompt that has gone from Salesforce to the LLM. Now, this is not the prompt that you defined. Like the prompt that you defined may be only this part. But we add a bunch of system prompts to prevent prompt injection and stuff like that. So you get to see all of that. And if we have masked the prompt, you can actually see what data we have masked, all the sensitive data. Now, if the response comes back, we show you that response, unmasked response, and so on. So very clear on what is happening behind the scenes. And this is all that there is, because in the end, what I wanted to show you with this is Data Cloud. When it comes to Agentforce, it's not just about giving data to the agent, but also tracking all of the data that the agent gives out. And it's not just limited to these LLM responses, but all your sessions, all the chat conversations will also be slowly moved to Data Cloud for you to nicely report and audit. So again, as a quick summary, there's a whole lot of things that an agent needs, and Data Cloud is going to be that solution that is going to empower the agents. So with that, we are at the end of the talk, and if you want to know further, because these are two different topics, Agentforce and Data Cloud, I'll have to put a whole bunch of resources. The easiest way is to go to our Salesforce Developers YouTube channel or the developer blog, where you have all of these data in one single place. So with that, I'd like to thank all of you for joining me today, and I hope you have a wonderful rest of the event, and I hope to see you soon.